So, last class it was about standard penetration test. By means of split spoon samplers and the hammer (65 kg), height will be 75 centimeter falling. Number of blows recorded second and third 15 centimeter and 15 centimeter penetration, that is 30 centimeter penetration, that is your number of blows n. Now, this is all about standard penetration test. From standard penetration test you can find it out phi, you can also find it out undrained shear strength Cu. Indirectly from n you can get also bearing capacity of footing, because the moment from n you get phi. Once you get phi, you can calculate the bearing capacity of the footing. Suppose there is a footing lies below 2 meter depth. If you have n values, if you have penetration blow values of each layer, layer 1, layer 2, layer 3, say n1, n2, n3. From penetration blow value you can find it out phi. Once you get phi, then you can calculate NC, NQ and N gamma. Once you get NC, NQ and N gamma, you can find it out bearing capacity is equal to CNC plus gamma DF NQ plus 0.5 gamma B N gamma. If it is a purely cohesionless soil, then you can get gamma D F N Q 0.5 gamma B N gamma. This is the utility, means application of SPT, standard penetration test, particularly for cohesionless soil, Now, there is another test that is called dynamic cone penetration test. In dynamic cone penetration test, the difference between SPT and DCPT is, in dynamic cone penetration test, a cone of 60 degree angle, apex angle, attached to drill rod. This is your drill rod, and soil blow by means of 65 kg of hammer, falling at a height from 75 centimeter distance. So, the difference between these two, SPT and DCPT, this is called DCPT, dynamic cone penetration test. This is called SPT, standard penetration test. The difference between SPT and dynamic cone penetration test, in DCPT no need to go for a borehole, You can record the penetration blow by means of a cone attaching to the drill rod, and a hammer is 65 kg, it is falling height is 75 centimeter. You just by means of hammer, this draining rod has been pushed, and continuously you recorded what is the value of n every 1 meter interval. Now, so there is a The advantage of this dynamic cone penetration test is no borehole, no borehole required. Now, correlation between SPT and DCPT. So, DCPT is your dynamic cone penetration is equal to 1.5 sorry 15 minus 2 into n corrected. So, NCT is equal to obtained from DCPT, dynamic cone penetration test, n corrected obtained from SPT. If you look at this n corrected, that means from SPT whatever you are getting from field, that is your n. Now, as I said, SPT n correction has been made. There are two correction, one is for overburden correction and other is your dilatancy correction. If you have NCD, dynamic cone penetration test, from there you can find it out what is the value of n corrected value of SPT. This is the correlation. Now, if I draw a graph it will be 0 to 35 n value from SPT and this will be 40, 0.5, 1, 1.5, 4.0, this will be 4.0, 0.5, 1.0. So, this is QU in kg per centimeter square. This is your unconfined compression strength. From this, if I draw here very stiff, medium, soft, very soft. Here also it can be made it this way, soft, medium, stiff and very stiff. Stiff, medium and here it is soft. So, to judge the consistency of soil from NC value, general practice is used to convert NC is equal to N by C. So, if it is NC is equal to from dynamic cone DCPT, N is equal to from SPT uncorrected, so C is a constant, its value varying from 0.8 to 18, then you can get directly from this. Here you can get, if you know the C value, constant value, you can put it from DCPT, you can find it out N. Then once you get N, you can correlate, you can find it out what is your unconfined compressive strength of cohesive soil. These two methods particularly, if you look at here, one is SPT, one is your DCPT. These two methods, it has advantage and disadvantage. In this case SPT, you have to go for borehole. The cost is slightly higher than the DCPT, dynamic cone penetration test. In case of DCPT, there is no borehole, but the disadvantage of the DCPT, dynamic cone penetration test, suppose there are boulders or maybe rock or maybe hard stratum, boulders. So, this cone may not be penetrate inside the ground, it will obstruct, that means it will give misleading result. So, if I compare both these cases, SPT is preferred, though it is slightly costlier than your dynamic cone, because in this case SPT you are doing the borehole. DCPT is preferred where you will get a soil from medium to soft kind of soil or loose to medium kind of soil, where this cone can be penetrated easily without any constraint, so that you will get n value, accurate value of n. Either of the two if you do, then you can convert n value to DCPT value or DCPT value to n value. These parameters are going to useful for your all the designs of foundations. It will indirectly give the value of bearing capacity. Another one is it also give E value, which is equal to C1 n plus C2. This E value is modulus of elasticity. It is given by, you can find it out once you know the n value. It is given by Magenbach 1961. Once you know the n value and C1, C2 are functions, these are the functions, it depends upon type of sand. So, if you know the n value from standard penetration test, so E value modulus of elasticity can be correlation, from correlation can be correlate, you can get the E value. Where this E value is going to use? It is going to use for immediate settlement of sand as well as clay, because these are the two parameters, E mu, it is settlement, for phi for your bearing capacity. So, indirectly or directly you can say standard penetration test is more advantageous than your dynamic cone penetration test, but dynamic cone penetration test is feasible once the soil layer is soft to medium or loose to medium available. Otherwise, because of obstruction due to boulders, it may not possible to get accurate value of n. Now, next test is your standard cone penetration test, or you can say static cone penetration test, it is called SCPT. In static cone penetration test, it is a sounding test. Continuous record of soil characteristics, it records soil characteristics. From there, once you record the soil characteristics, from there indirectly you will get it engineering properties. It does not need any borehole. A 60-degree cone of base area 10 centimeter square with friction jacket. From here you can find it out cone resistance QC. QC and also frictional resistance. Now, it has been changed, modified. SCPT, static cone penetration test, has been modified as electrical piezo cone. It has tip resistance, side resistance, then pore pressure. Now, how it works? If I draw it in figure, how it works? Look at this figure. One, 2, 3, this is 4, this is A. With further down of this cone, there are 3 the functions has been shown in 3 parts. this is B, now here to here is B, now this is A. So, 1 stands for sounding rod, two for bottom mantle tube, three for friction jacket, 4 for this cone. If you look at here, this assembly, this is your sounding rod, this sounding rod is directly connected to your cone, and this has been assembled with bottom mantle tube, and this is your friction jacket. Now, the arrangement in such a way that once it is in the ground surface, if you lock this, now it will move as a whole. It will move as a whole, that means cone plus friction jacket will move simultaneously. If you remove this lock, this arrangement has been made in such a way that there is a lock here. If you remove this lock, that means only cone will move, and at the surface the arrangement is there, you can measure the pressure or the resistance you can measure at the surface. So, what will happen? Suppose we want to find it out continuous cone resistance without any frictional resistance. So, what will happen? You just unlock this, so that with this sounding rod as you push it, then it will come as if a cone is moving below this, and this part will be remain in the ground, above the ground, this part will be remain above in the ground, this frictional jacket. So, from this only you will get cone resistance, Where it is applicable? Look at this pile. In case of pile, there are different types of piles. One is your frictional pile, other is your end bearing pile, other is your friction plus end bearing piles. In end bearing piles, you want to know what is the cone resistance or tip resistance. That means, in this case you will find it out only QC, Now, the moment I lock, there is a locking arrangement, the moment I lock it, whole assembly will move, This is shown that this is a case A, this is your case B, this is your case C. Once you lock it, whole assembly will move inside the ground. Means from this what you are going to get, because it comes inside, this will give frictional resistance, also this will give cone resistance. Once whole assembly move inside, from here you are supposed to get total resistance. So, initially you have your cone resistance, then you have your total resistance. If I remove from total resistance to cone resistance, then I will get it only frictional resistance, So, this is called total, this is called your static cone penetration test. What are the parameters you are going to get? One thing you are going to get is your cone resistance, other is your frictional resistance. That means the test once you are going to do, first you put in the ground, so that you unlock this, so that cone will be pushed inside, keeping this resting on the ground, so that first you will get cone resistance. Then what happen? Then in the second stage, in the same soil profile, you lock it, whole assembly will move along with this cone. Once whole assembly will move along with this cone, you will get total resistance. So, if frictional resistance you want to find, then it will be total resistance minus cone or tip resistance. Total resistance minus cone or tip resistance, then you will get frictional resistance. Now, how this frictional resistance is useful? In pile foundation, where this capacity has been carried by friction piles, in that case what will happen? This capacity will be taken by the pile with periphery or the frictional resistance. So, you will get directly from this what is the frictional resistance of this pile supposed to be, you can find it out directly F. Now, these are the all sounding tests. In this case you will get continuous record of the soil, and you can indirectly correlate with this QC, you can find it out what is the engineering properties of soil. In this case you do not need any borehole, and it is basically the mechanism is a 60-degree cone. This is your 60-degree cone, and base area 10 centimeter square with a frictional jacket, and this is your frictional jacket with a frictional jacket. And from there you will get cone resistance and frictional resistance. Now, this has been slightly modified over the years. So, SCPT has been changed to electrical piezo cone. Now, in this electrical piezo cone you will get tip resistance, that means QC, tip resistance or cone resistance, side resistance or frictional resistance. At the same time you also get electrical piezo cone. By means of electrical piezo cone you will get pore pressure, that means in the ground surface how the variation of pore pressure is there. This will be required for liquefaction analysis. Now, with a single test, this is your depth, you will find it out. This is my QC cone resistance, you also find it out how much is your frictional resistance. Also you can find it out what is the variation of pore pressure. If you know variation of pore pressure in situ condition, then easily you can analyze for liquefaction analysis or maybe earthquake analysis, whether if there is an earthquake then pore water pressure will rise, then soil will liquefy or not, that can be analyzed. So, frictional resistance you will get QF by area of friction. So, QF load of friction you will get it total resistance minus resistance by cone, total resistance minus cone or tip resistance, it will be QF minus QC divided by area of the frictional jacket. You can, this diameter is given, length is given, you can find it out from the diameter what is the area of friction. So, once you get the frictional resistance you can plot cone resistance, frictional resistance, as well as also pore water pressure resistance, you can plot it. Now, next step is, these are the 3 prime tests. One is your standard penetration test, other is your dynamic cone penetration test DCPT, third is your static cone penetration test or cone test SCPT. These particularly these 3 tests, it has wide range of application. So, SPT, basically first one SPT is standard penetration test. SPT is for particularly cohesionless soils, you can find it out phi. Also SPT can be carried out particularly C phi soils also. From there are correlations given by Terzaghi and Peck. Once you know the N, from N value you can find it out on-drain strength, on-drain shear strength of the soil. You can classify whether it is a loose, soft or maybe stiff or very stiff. Then third one is your cone resistance or static cone resistance. In this case, the advantage is if there is a pile foundation is to be constructed, or maybe a purely clay soil is there, purely cohesive soil is there. From there, for particularly that you will get QC, end bearing of cone. If there is a pile foundation, suppose this is an area where it has been decided, pile foundation construction. So, for pile foundation you need to have your what kind of piles you are required, either it is a end bearing or friction piles or both end bearing and friction pile. In that case you should able to say that each layer wise, each layer how much the tip resistance, how much the frictional resistance, how it is varying, so that you can decide if you will go for pile foundation, what should be the length and what is the diameter of pile you are supposed to do. So, suppose it is an end bearing pile, then in that case you have to pick only QC, tip resistance. Suppose there is, say it is the pile foundation to be constructed so that it will take load by means of friction or frictional resistance of the pile, you can get it by means of frictional resistance of your cone. If it is a mixture of, like the pile may be considered as both friction as well as end bearing, then in that case you take into account of your total resistance. Total resistance is nothing but frictional resistance as well as your tip resistance.